Hi class, today is lesson 2-5, addition equations. Let's go ahead and go to the purpose. Today's purpose is to solve whole number addition problems algebraically. What you'll find as we do this lesson that the problems are pretty easy to solve, yet I'm not interested in so much as the solution as I am the process. So we're going to be solving these problems algebraically, and that's the key. We do have one vocabulary term, and that term is inverse operation. Inverse operation is an operation or operations that undo each other. Here we have addition will undo subtraction, and vice versa. Subtraction will undo addition. Well, what about multiplication and division? Well, same thing. Multiplication will undo division, and division will undo multiplication. As we look at our examples, you'll have a clear picture of this. Let's go to our examples. Here we have a pretty simple problem that we can solve, maybe even mentally, but I want to deal with this algebraically, and you need to go ahead and learn how to do this algebraically. This is x plus 62 equals 93, and it tells us in the directions we need to solve each equation, which means we need to find out what x is. In fact, we need to get x all by itself on one side of the equation. So going down to this scale, don't copy this scale, I'm going to write down the x plus 62 right here on this side of the scale and the 93. Because this is an equation, this side is equivalent to this side, and if we were to measure it on a pan balance scale, these sides would be level. Now, what we're going to do first is we're going to isolate the variable, or attempt to isolate the variable, by undoing an operation. What do I mean by isolate the variable? My objective is to get x all by itself on one side and the solution on the other side. So in order to do that, I'm going to subtract 62 from this side. Well, if I subtract 62 from this side, the equation becomes unbalanced, and I need to do the same thing to the other side. What I do to one side, I have to do to the other side. So what happens is the 62's go away. 93 subtract 62, I can actually do in my head, and it's 31. All right, so x equals, in the end, 31. Now, I don't want you to copy this down, yet I want you to copy down what I do, the actual equation up here. You're going to go ahead and write down x plus 62 equals 93, and then I want you to draw a line under there. And this is going to be similar to a pan balance. And underneath the equal sign, we're going to put the fulcrum. That's the point of pivot for this scale. We're going to do the same sort of thing. X plus 62 equals 93, and there's our balance. Now, we're going to show that we're going to subtract 62 from both sides. And when we subtract 62 from both sides, we're going to be able to maintain that balance. The 62's go away, so the x drops down, and we wanted to isolate the variable. We want x by itself, and now 93 subtract 62 is 31. There's our answer. Okay. Now, let's go to this second problem. This time the y is on the other side. We're going to draw the same sort of pan balance. And we're going to draw the fulcrum right underneath there. That's the pivot point. We see that we need to isolate the variable, get the variable all by itself on one side. And in order to do that, we need to undo the addition. We need to get rid of plus 17. How do we get rid of plus 17? Well, we subtract 17, because that's the inverse operation. What we do to one side, we have to do to the other side in order to keep this scale in balance. We come up with 17 minus 17 is 0. We get rid of that. The y drops down, and 81 minus 17. Well, 81 minus 17 we can do off to the side if we can't do this mentally. 11 subtract 17 is 4. 7 subtract 1 is 6. So 64 equals y. Notice that the y is on the same side as it originally was, and the answer is on the other side. This is fine. We could switch it around, and in the end we could say y equals 64 to kind of match what we want, but this is fine. We have simplified it down to what the value of y is. Example 2, here's a story problem of sorts. It says Tulsa, Oklahoma City, and Lawton are located in Oklahoma as shown on the map. Here's Lawton, Oklahoma City, and Tulsa. Find the distance d between Oklahoma City and Tulsa. So they've given us these distances. Here between Lawton and Tulsa it's 175 miles. Between Lawton and Oklahoma City it's 75. And what we've got to find out is what's the distance between Oklahoma City and Tulsa. So what we're going to do is we're going to set up the equation. We know that the entire distance between Lawton and Tulsa is 175, and that would equal this distance, Oklahoma City to Lawton, plus this distance, Oklahoma City to Tulsa. So these two distances added together would equal 175. 175 equals 75 plus d. So we're going to go ahead and solve in that case. I'm going to copy down that problem. 175 equals 75 plus d. Now this is easy to do mentally, but again we're going to do it, we're going to show it algebraically. I want to isolate the variable. In order to isolate the variable, I've got to get d by itself and get rid of this plus 75. I'm going to draw the pan balance scale, or something that looks like it, the fulcrum right underneath the equal sign. And then I'm going to say, well, what do I need to do to undo the plus 75? Well, it is, of course, subtracting 75. Now, what I do to one end of the scale, in order to keep it in balance, I have to do to the other end of the scale. So I subtract 75 from the other side. Then 75 subtract 75 is 0. The d drops down. And now I have 175 subtract 75 on the other side, which is 100. Now I've got to label that, of course. D equals 100 miles. Okay. Now, I want you to go ahead and solve two problems and show your work algebraically. Again, I want you to use a pan balance scale with a line that acts as the pan balance and a triangle underneath the equal sign that acts as the fulcrum. How do we isolate the variable in both these situations? How do we get rid, how do we undo a plus 42 over here and a plus 35 over here? All right, I'll look forward to seeing your solutions. We'll see you in class.